Hello, this is Adrienne Kalish and welcome to my final presentation for CSCI E-89 Deep Learning. In this presentation, I will go through the technologies I used for object classification of your favorite photo. Problem statement. Use tools within deep learning to classify objects within images. For image classification, two different techniques were used, VGG16 and TensorFlow Hub. Listed below are some of the advantages and disadvantages used in this demonstration. Advantages. Throughout my work on this project, I came up with the following conclusion. Object classification tools work well on obvious photos. In addition, deep learning tools for this technology were easy to set up and easy to use. Some of the disadvantages. This technology does not work well on photos of humans, but does seem to work well on photos of animals. In addition, this technology also fails when a photo is very detailed. Software used in this demonstration: Python 3.6.8, Keras 2.2.4, TensorFlow 113.1. Working example. 1. Collected images to be used for object classification. 2. Tested object classification using VGG16 technology on my favorite photo. 3. Tested object classification using VGG16 technology on other photos in my dataset so that I can see its performance. 4. Tested object classification using TensorFlow Hub technology on my favorite photo. 5. Tested object classification using TensorFlow Hub technology on other photos in my dataset so that I can see its performance with other images. Here is an image of my favorite photo that I will use for this demonstration. In my first example, I will be using VGG16 to classify objects within my image. As a first step, I have imported several libraries, including Keras, OS, NumPy, and VGG16. In addition, I have also imported several modules within Keras. To get VGG16 up and running, I have configured it as follows. I then clear my session and import my photo. As you can see, my photo is on my local computer, and I have set a target size. I then use the prediction function to classify my loaded photo. As you can see in my code, I have asked for 3 predictions. My 3 predictions are Egyptian cat, tiger cat, and tabby cat, so not too far off, although I would certainly not classify her as a tiger. I then plotted my results in a bar chart. After I was pleased with my results, I decided to test the tool. I uploaded a less obvious photo of a tray of chocolate chip cookies. My results were interesting. It determined that there was a tray in the photo, but ignored the cookie. In my next example, I decided to switch gears and use a different technology. I installed TensorFlow Hub. Within TensorFlow Hub, there's a library of deep learning modules which span across different modules such as text classification, image classification, and video classification. I installed TensorFlow Hub and imported the libraries I needed for this demonstration. I then imported a classification tool I found on the internet and started my TensorFlow session. After that, I imported some additional libraries, loaded my image, resized my image, and added in a prediction function. As you can see, I received 1 prediction of an Egyptian cat, the same prediction I received with VGG16. Like I did in my prior example, I was happy with my prediction, and I decided to try this on a less obvious photo. Here is an image of a toddler. Again, I loaded the photo, resized my image, and added in my prediction function. The results were off, and I did not seem to classify this correctly. The classification is swing, and I'm not clear on how it came to that conclusion. For my last test, I loaded in more than one image. In my previous example, I classified objects one by one, and in this example, I'll attempt to classify 4 images. Again, I loaded in each image separately, resized each image, and added in my prediction. The 4 photos used were that of a telephone, a beer glass, a baby, and the beach. Out of the 4 objects below, the phone was classified as a sandal, the beer glass as a beer glass, the baby as pajamas, and the beach as a seashore. So its accuracy is pretty simple at 50%. I can understand why it incorrectly classified the telephone, as it's not such a common object these days. I also mentioned at the beginning of this presentation it does not classify humans correctly. In conclusion, 2 technologies were used for object classification of my favorite photo, as well as object classification of other photos. I used VGG16 for object classification and TensorFlow Hub. Within TensorFlow Hub, there is an image classification module. 6 images were used in this demonstration, including my favorite photo of my cat. My cat was classified correctly, more or less, so I decided to test the tool on some additional images. Some of the images were obvious, such as a beach and a beer glass, and others were not, such as a tray of cookies. As a test, I also included 2 images of humans, a baby and a toddler. As I mentioned earlier, object classification works pretty well, with good accuracy for very obvious photos like cats, beer glasses, and probably dogs. It does not work well with humans and did not correctly predict some of the objects in my dataset.